Venterea is next.
Okay, so I'm an adjunct assistant professor, a member of the grad faculty. My primary position is with ARS, Agricultural Research Service. There are several of us walking around. You can't really tell just by looking at us who we are. We're federal employees. Therefore, much of my research is done using support scientists that are ARS employees, being Mike Dolan, who's really the backbone of my research program. And right now we also have Vincent Tan, who's a recent graduate of EEB. But the really excellent aspect of this position is that I get to collaborate with the folks here, and I continue to collaborate with many folks and their students, as well as being able to advise, co-advise my own students and postdocs. And right now, Florence Sessoms, I've been working with as a postdoc, collaborating with Mike Sadowski, and Emerson Cordova as a postdoc, collaborating with Carl. And so, my research interest is basically focused on reactive nitrogen cycling in and losses from agricultural systems, and of course this is associated with many environmental problems, agronomic constraints. My program basically can be broken down into 3 parts: replicated plot studies, which we've done a lot of over the years, looking at management effects, combined with lab studies to look more at specific processes and mechanisms, and then we have a modeling component as well. And that's what I'm passionate about, all the reactions going on there. Of course, that's only one small part of the nitrogen cycle. I like to solve problems in general, whether it's my children's homework problems or experimental design challenges, chemical analyses, things that come up every day, and collaborating with people having different perspectives, scientific and cultural. And so our plot studies, fairly traditional, although we like to measure multiple components of the system, multiple species within those components, and use experimental designs that evaluate multiple factors and potential interactions between those factors. So what I'm going to do is just go through a few of our recent findings to kind of give you a better concrete case for what we do. We found that switching from anhydrous ammonia to urea reduced N2O emissions by up to 70% in more than one location over several site years, with a trade-off of higher NO emissions with urea. We think we understand from a basic process level why this is happening. We also found in an early study subsurface placement of nitrogen fertilizer in no-till systems can reduce N2O emissions substantially compared to conventional till. And we found this to be true also in a meta-analysis that we did several years later. A recent student of ours, Bijesh Maharjan, found banded urea application increased N2O by 100% compared to broadcasting, but the effect was lessened or avoided using nitrification inhibitors. In general, we're finding nitrification inhibitors have been effective in reducing N2O, and the current research now is focused on comparing the several different products that are out there and being commercialized by different companies, and that's the project that Carl and Emerson and I are working on right now. In the laboratory component, we take the soil into the lab and do a variety of methodologies to try to focus in and explain what's happening basically under field conditions, under more controlled conditions, and also we can quantify parameters from these experiments that potentially can be used in modeling studies. I'm particularly interested in the role of 2 compounds, free ammonia and nitrite, that aren't commonly measured or thought about too much in nitrogen cycling studies. And recently working with Mike Sadowski and Flo, we've been combining measurements of microbial gene abundances together with chemical substrate measurements and finding this is a powerful method to explain the variance in N2O emissions that we're seeing across different soil types.